Hello future doctors, welcome to Gyansrota. Today we are going to start the PYQ session of the NEET 2017 question paper. So first question is on your screen. Which of the following is a sink for carbon monoxide? So now we are moving to the solution part. So if you see in this question is come from your environmental chemistry of your class 11 NCERT, and you see the option number 1, that is the microorganisms present in the soil, it is a sink for carbon monoxide. So option number 1 is the correct answer of question number 1. So now we are moving to the question number 2. So question number 2 is on your screen. The element Z is equal to 114 has been discovered recently. It will belong to which of the family, group and electronic configuration? So now we are moving to the solution part. So this question is basically come from the very first chapter from your chemistry 11, that is the some basic concept of inorganic chemistry, or you can say it is coming from the electronic configuration part. For that you should know only the radon atomic number. What is the radon's atomic number? That is your 86. Now remaining, if you plus it this part 14, 10 and 2. So let us see what you got. So 14 plus how many electrons? This d orbital T, 10 electrons. So for 2 S is 2 and for P is 2. So what will coming? 6, 4, 10, 12, 13, 14, 4, 1, 10, 11, sorry 14, 9, 10, 11. So 114. So if you see 114 is come from the first option. So that J 114 is come under carbon family, and option number 1 is the correct answer of your question number 2. So now we are moving to the next question, that is question number 3. So question number 3 is on your screen. For a given reaction, delta H equal to 30.5 kilojoule per mole and delta S is equal to 83.6 joule per Kelvin per mole. The reaction is spontaneous at, assume that delta H and delta S do not vary with temperature. Now we are moving to the solution part. So if you see in the questions, they are mentioning that spontaneous, and when it will be spontaneous, we know that delta G should be negative. Okay. This is the condition to get your spontaneous reaction. Now what is the formula of delta G? Delta G is equal to delta H minus T del S. Now if you see, to get this term negative, this term, that is the negative term, should be greater than your delta H. Just give you an example, like suppose if you want minus 5, what you will do? Here you have to put 5, then minus 10, means that negative part is be greater than your other part. Similarly, to get the negative delta G value, this T del S value is greater than your delta H value. Now these conditions we are going to use to solve this equation. Okay. So what you got? You got the T del S value is greater than your delta H value. Now if you see in the conditions, the condition number 4 is already cancel it out, because here they are mentioning T less than 425. This is should not be right answer. Okay. Now all the temperatures, that is also we can neglect it out. Okay. Now we have left it out only one, option 2 and option 1 and option 3. Now let us see T, delta H and delta H. And what is the value of delta H? It is coming as 35.5 kilojoule per mole. And what is the delta S value? 83.6 joule per Kelvin. Okay. Now if you solve this one, you will get 425, means this tree is always be greater than your 425 5. See, in the options where it is, option number 1 where T is greater than your 425, here also T is greater than, but this value is not matching the calculation part. So, option number 1 is the correct answer of question number 3. So, question number 4 is on your screen. Identify A and predict the type of reaction. Now, we are moving to the solution part. Now, what is the reactant they are given? So, this is the reactant they are giving and they give you NaNH2. Okay. So, this NaNH2 you can write as NH2 minus. Okay. NH2 minus you can write. So, this is nothing but this is your base, and what base will do? It will abstract the proton. Now, see, here also hydrogen is present and here also hydrogen is present. Okay. But this hydrogen is more acidic compared to this. Now, what is the reason? See, this hydrogen is the sandwich between these two electron withdrawing groups. So, electron withdrawing groups will always be favored to give you the more acidic protons. So, what will happen? This base will abstract this proton, not this. So, after take out this base by abstracting this proton, what you will get? See, this is gone. And by abstracting this proton, that is in H plus, so here it will be minus. So, here minus sign will be coming and here is bromine. Now, what will happen? This minus will be going this side and your bromine will be left out. So, you are end up with this product, and this product is nothing but this is your benzene intermediate, and we all know the benzene is highly unstable. When it is highly unstable, these are more reactive. Now, after that what you have? You have an NH2 minus, because here base will be there. So, you have this NH2 minus. Now, this NH2 minus is act on this side, or it will attack on this side. So, I am mentioning here is as A and this part I am mentioning as B. Now, if it will attack through A, okay, what will happen? If we will attack through A, so this NH2 will attack here and this bond will shift on this side. So, you are end up with this kinds of product. Now, if it will follow this B pathway, then what you will get? If you follow this B pathway, then this bond will be break on this side, means you are end up with so it will attack on this side, this bond will break on that side, means here this minus sign will come and here your NH2 group will be attached. Now, if you see this one, your first one who followed the A pathway is less stable. Why it is less stable? Because see, this negative sign, if it is near to this electron withdrawing group, then it is highly stable. But in this case, this negative sign is far away from your electron withdrawing group. So, as a result, this intermediate or this adduct is less stable. If you compare this B product, means the compound which follow this B pathway, this is highly stable. Why it is highly stable? Because this negative charge, it will be stabilized by this electron withdrawing group. So, whatever product we are getting, we have to follow this one. Now, after that, what will happen, your NH2 group, and here they are reaching as H plus, and you will end up with this product. And if you see that reactant where your bromine is present, that place is replaced by the NH2 group, means the same place. So, if it is bromine group or halogen group is replaced by the same position with the different group with the same position or same carbon, then this types of process is known as your substitution process. Or if it will be not replaced by this position, instead of this position, if it will follow this order, then this types of process is known as syn substitution. But here it will be follow this substitution, because here bromine is in this carbon, the bromine is present if you see in the reactant. So, that is why this position is replaced by NH2 group and you will end up with the substituted product, and this is the correct option. Option number 4 is the correct answer of your question. So, if you see, these are the options of question number 4. So, if you see the first one, elimination addition, another one is syn. Syn is not possible, because see, if syn is required, then this bromine part will be replaced. Okay, syn substitution is not possible, and here also the product is not possible. So, this option we can neglect it out. Now, this syn substitution, here this NH2 group is even not there. So, this is not possible. You have to left it out option number 1 and option number 4. Maybe you are getting confusion between elimination and addition reaction, because benzene formation, it followed this elimination addition reaction, but here after that benzene also the reactions proceeds. So, after reaction whatever is proceed, that is proceed through a substitution reaction. So, option number 4 is the correct answer. Now, we are moving to the next question, that is question number 5. So, question number 5 is on your screen. Which of the following is dependent on temperature? So, now we are moving to the solution part. Now, if you see molarity, and what is the formula of molarity? Number of solute divided by liter of solution. So, this is nothing but this is the volume, and volume always change with temperature. So, what they ask you, following dependent on temperature. Now, among this 1, 2 and 3 option, which one is dependent on temperature? So, your option number 1, molarity, is dependent on temperature. So, option number 1 is the correct answer of your question number 5. Question number 6 is on your screen. With respect to the conformers of ethane, which of the following statement is true? So, now we are moving to the solution part. So, if you see, they are saying that conformers of your ethane molecules. Okay. So, here see bond angle changes, but bond length same. No, this is not the option, because in conformations your dihedral angle will change. Not your bond angle. Okay, bond angle is not change, bond length also not change. Your changing part is your dihedral angle. So, if you see option number 1 is, we can neglect it because bond angle changes they are mentioning. If you see the option number 2, both bond angle is again they are mentioning, so it is not possible. If you see the option number 3, both bond angles and bond length remain same, and option number 4, if you see, bond angle remains same but bond length changes. I already said bond length and bond angle will not change. So, option number 4 will be not the correct answer. Option number 3, where you say both bond angle and bond length remain same. So, this is the correct statement or correct answer of this question, question number 6. Now, we are moving to the next question, that is question number 7. So, question number 7 is on the screen. Name the gas that can radially decolorize acidified KMnO4 solution. Now, we are moving to the solution part. So, if you see in options, this SO2, that is sulfur dioxide, is act as your reducing agent. So, this sulfur dioxide can easily decolorize this KMnO4. So, your option number 1 is the correct answer of this question. Now, I will give you a reaction how it will be formed, like KMnO4 when it react with sulfur dioxide with water, it will give K2SO4 plus MnSO4 plus H2SO4. So, this is not balanced, so you just put the stoichiometry to check the balance, but this is the actual reaction how this sulfur dioxide decolorize this KMnO4, because these are act as a reducing agent, and this statement is given on your P block element of your class 12 NCERT, not that class 11 part. Class 12 NCERT, these reactions and this statement is already given. Now, we are moving to the next question, that is question number 8. So, question number 8 is on your screen. It is because of inability of NS2 electrons of the valence shell to participate in the bonding that. So, now we are moving to the solution part. So, if you see here your SN, PB, these all come under group 14 series. So, like carbon, silicon, that is college students get some problem. So, we are not required this part, we are going to consider only these three. Now, when you are moving down the group, so what will happen? Your F cell is increases, and we all know F cells are poor shielding. So, what will happen? Your electrons are more closely contact with your nucleus. So, as a result, it is very difficult to pull the electrons from the valence shells. So, as a result, the lower oxidation state more stable. So, what will happen when you are moving down the group? Your F subshell is increases, and F subshell we all know they show poor shielding effect. So, what will happen? The electrons which is present in the valence octet or valence orbital, it will be more strongly connected with the nucleus. So, it is very difficult to pull these electrons. So, as a result, lower oxidation state become more stable. So, Ge2 plus, Sn2 plus and Pb2 plus. So, the stability order that Pb2 plus is more stable than Sn and then Ge. But if you say Ge4 plus, Sn4 plus and your Pb4 plus, so the stability order is Ge4 plus is more stable than Sn4 plus than your Pb4 plus. Now, this concept we are going to use to solve this question. So, what will happen? Pb4 plus is more stable to Pb2 plus. So, what will happen? Pb4 plus, it takes 2 electrons and convert it into Pb2 plus. So, this process basically called is your reduction process. So, what will happen in reduction process? Your Pb4 plus, it's gain 2 electrons. So, these 2 electrons is lost by someone else. So who will help this losing process? That Pb4 plus. So that's why Pb4 plus is called is your oxidizing agent. So don't get confused, the reduction process is led by a reducing agent. No, reduction process, who will help this one? That is your oxidizing agent. So Pb4 plus is act as your oxidizing agent. Now if you see among your option, Pb4 plus is reducing, which is not possible. So option 1 we can neglect it. Pb2 plus are both oxidizing, it may be. SN4 plus is reducing while Pb4 plus is oxidizing, that is may be correct. In fourth also Pb4 plus is oxidizing, that may be correct. Now in another one, that is your SN2 plus and SN4 plus. So SN4 plus is more stable. So what will happen? SN2 plus lose 2 electrons. So this process basically called is your oxidation process. Now this 2 electron is gained by someone else. So who will help to this gain these 2 electrons? That is SN2 plus. So SN2 plus is act as your reducing agent. So Pb4 plus is your oxidizing and SN2 plus is act as your reducing agent. Now if you see among all the options, first option SN2 plus is oxidizing, which is not possible because SN2 plus is act as your reducing agent. Second option SN2 plus and Pb2 plus are both are oxidizing and reducing, no, it is not possible. Third option SN4 plus is reducing, no, SN2 plus is reducing. So option 3 also we can neglect it out. So we have left it out only one option, that is option number 4. SN2 plus is reducing agent and Pb4 plus is your oxidizing agent. So option number 4 is the correct answer of your question number 8. So question number 9 is on your screen. Mechanism of a hypothetical reaction x2 plus y2 2xy is given below. The overall order of the reaction will be. So now we are moving to the solution part. So now we are moving to the solution part. First of all, find out the rate. Okay, so three steps are there. So from which steps we will get the rate? We will get the rate from the second step, because second step is your slowest steps. So how to find out the rate? Rate is equal to x and y2. So this is the rate of this reaction. Now if you see for the first reaction, this reaction formed here, we can find it out that if I am taking this reaction or this steps is a reversible step, then what you will get? You will get the K equilibrium is equal to your product concentration, that is your x square divided by reactant, that is your x2. Now just replace one, x you keep on this side and K equilibrium is going to that side and x2. Now if I remove this power, so what you will get? X K equilibrium to the power half and x2 to the power half. So when you remove this power, what you will get? You will K equilibrium to the power half, x2 to the power half. Now replace this x terminology into your rate reaction. So what you will get? You will get x, that is here one constant will come, that is your rate constant. So K equilibrium to the power half, and what is this? x2 half and your y2. So now how to find out the order? We have to just add on these powers, that is half, and here its 1 is there. means your order half plus 1, that is 3 by 2, that is 1.5. So, 1.5 is the correct answer of your question number 9. So, if you see the option number 3, that is 1.5 is the correct answer of this question. Now, we are moving to the another question. So, question number 10 is on the screen. The equilibrium constant of the following are the equilibrium constant of the reaction. So, now we are moving to the solution part. So, if you see these 3 reactions, they are given to you. So, first let us see this one. Okay. So, first of all, this reverse this reaction. So, if I reverse this reaction, that is NH3, your N2 plus 3H2. So, what will happen, this constant is also gone to the reciprocal. Now, if you see in the K3, this one, this last reaction, if I multiplied with 3, so what you will get? You will get 3H2 plus 3 by 2 O2 and 3H2O. So, if you see this reaction, if I multiply with 3, you will end up with this, and as the result your equilibrium constant also it's going to the power of q. So, it is always be remember, when we reverse of any reaction, then that equilibrium constant or rate constant, whatever they are given, it is always go into the reciprocal format. And when that reaction is multiplied with any number, then your this constant is also the power of that multiplied. Like here it is a multiplied with 3, so that is why it is power of 3. If this reaction is multiplied with 4, then I have to write like K3 to the power 4. If it is multiplied with 5, I have to write as K3 5. So, now you have to end up with this reaction and this reaction. Now, remaining, if you see the constants 1 by K1, 1 K3 cube and K2, when you add up those reactions, your constants values is going to multiplied. Like here what will happen, here is K2 into K3 to the power cube divided by K1. So, this is the rate constant or equilibrium constants of your resultant equations. So, this concept is basically given in your equilibrium chapter of NCERT is 11. So, here nothing but always focus on this part, like if I reverse of any reaction, then our constant is also goes to reciprocal, or if it is multiplied with any numbers, then whatever constant is there, that power is the multiplied of this same number. Like here K3 to the power 3, how 3? Because it is multiplied with 3. If it is multiplied with 4, then it go to the K3 to the power 4. So, similarly, if it is reactions any divided by 3, then your new constant will be coming like 3 to the power k. Okay. So, this is the way how you have to solve this equilibrium concept. Just focus on this concept and this one. When you add up these reactions, your equilibrium or rate constants always be as a multiplied form. So, this is the answer of question number 10. Now, we are moving to the another question, that is question number 11. So, question number 11 is on your screen. So, which one is the wrong statement? Now, we are moving to the solution part. So, if you see the first, the uncertainty here they are giving as a wrong. So, always I already told, when wrong, right, increasing, decreasing, you just first mark it. So, wrong statement they ask. So, if you see the uncertainty principle equation is a right statement. The half filled and fully filled orbitals have a greater stability, yeah, that is a right statement. The energy of twice s orbital is less than the energy of 2p orbitals in case of hydrogen, like no, this is a wrong statement. In monoelectronic species, always remember in mono electronic species like hydrogens and remaining He plus, those types of, their energy is directly proportional, or energy is the function of principal quantum number, and this energy value is Ns is equal to Np equal to Nd, and this is only followed by a mono electronic species, not your multi electronic species. So, always remember here 2s is equal to 2p. So, option number 3 is the correct answer of question number 11, which is the wrong statement.
The hepatic portal vein drains blood to liver from stomach, kidneys, intestine or heart. This is also from the chapter digestion and absorption. So, which among them is the correct answer for this question? So, the answer is intestine.